Euclid's Elements, Book 4, Proposition 2. In a given circle, to inscribe a triangle that is equiangular to a given triangle. We've got our given triangle, we'll call it A, B, C, and then we have our given circle. And our goal is to inscribe in this circle a triangle that is equiangular with this triangle. And inscribe in book 4 means that the vertices of the triangle will touch at the circumference of the circle. First step, he uses proposition 17 of book 3 to create a line GH that is tangent to the given circle at point D. Line GH tangent at D. And then using proposition 23 from book 1, from our given tangent point, we're going to construct two angles. First, we're going to construct angle HDF, which is going to be equal to the angle at A. And then we're going to construct another angle GDT, which is equal to the angle at C. Say that HDF equals the angle A, and that's GDT equals the angle at C. Now from proposition 32 of book 3, we know that the angles, when you've got a segment in a circle, like we've got DF here creating two segments, namely the major segment and then the minor segment here, we know that the angles in the alternate segments are equal. Therefore, the angle HDF is equal to the angle DTF, and the angle GDT is equal to the angle DFT. In step 4, we're going to use common notion number 1 using steps 2 and 3. So common notion number 1, we're basically going to use it twice. We can see that angle A is equal to HDF and angle DTF is equal to HDF. Therefore, angle A and DTF will be equal to each other. And then here, we can see that angle C is equal to angle GDT and angle DFT is equal to angle GDT. So C and DFT will be equal to each other. DTF equaling A and DFT equaling C. And now we can utilize Euclid says proposition 32 from book 1, which of course says that the three angles of a triangle are equal to two right angles. And I think you could probably combine this with common notion 3 as well, even though that's not given in the text, which is equals subtracted from equals makes the remainders equal. Because of these two, because of this proposition, this common notion, we can say that the angle at B is equal to the angle TDF. So the angle TDF is equal to the angle at B. And therefore, in our given circle, we have inscribed a triangle TDF that is equiangular with our given triangle ABC. Q, E,